This is the first video for distance measures. The objectives of this video are to define the distance between two nodes, the eccentricity value of a node, and the diameter and radius of a network. So what is the distance between two nodes? In the network below, we have two nodes, labeled U and V. The distance between U and V is the number of edges, or the number of links, that must be traversed in going from U to V along the network. You can also say it's the number of nodes that must be encountered as you go along any path from U to V, including V. So in our example below, the distance from U to V is 4. However, in most networks, there is more than one path between two nodes. So in our previous example, we've created another path from U to V. And we can see in our new path that it is a path of length 3. So it's the distance from U to V 4, or is the distance from U to V 3. We will define the distance to always be the length of the shortest path, so that our definition is now well defined. Now that we know how to determine the distance between any two pair of nodes, we now define the eccentricity value of a node. To determine the eccentricity of a node, we determine the distance from the node to each of the other nodes in the network. So if there are 6 nodes, for example, we would have 5 distances to calculate from that node to each of the other 5. Or in general, if there are n nodes, we'll be looking at n-1 distances. Now that we've found the distance from our node to all of the other nodes in the network, the eccentricity value of the node is the maximum value of the set. So let's look at some examples. Let's find the eccentricity value of a node U. The distance from U to X is 1, from U to Y is 2, U to Z is 3, and U to V is 4. So the maximum distance that we calculated was 4. So the eccentricity value of U is 4. On the other hand, let's look at the eccentricity value of, say, Y. The distance from Y to X and from Y to Z is 1, and from Y to U and Y to V is 2. So the maximum value of all of the distances is 2. So the eccentricity value of Y is 2. Do you know what the eccentricity values are of the remaining nodes? Do you agree with the table on the right? Because of symmetry, we can often see that since we calculated the eccentricity value of U to be 4, it's clear that the eccentricity value of V is also 4. Now, given that we have the eccentricity value of each node, we have a set consisting of all of the eccentricity values. In our example, the eccentricity values are 2, 3, and 4. The maximum value of this set of eccentricity values is called the diameter of the graph, or the network, and the minimum value of this set is the radius. So our network has diameter 4 and radius 2. In this case, the radius is exactly half the diameter. The diameter is 4 and the radius is 2. We know from geometry that the radius is always half the diameter, but in this case, it's not necessarily true that the radius is half the diameter. In a network, the radius can be larger than that. Suppose we change our network again, this time by adding an additional vertex or node that we will label W. And now we have a cycle network. What are the eccentricity values in this case? Now the distance from U to V is only 2. The distance from U to Z is 3. And the distance from U to all the other nodes is either 3 or less than 3. So U has eccentricity value 3. But we might notice that this is true for all of the nodes. If you look at W, it can be reached, or it can reach U and V on a path of length 1, X and Z on a path of length 2, and Y on a path of length 3. Each of these nodes has eccentricity value 3. So the maximum of the set is 3, and the minimum of the set is also 3. So in this case, the diameter and the radius are equal. Again, the set that we generate, the set consisting of all eccentricity values, is just a set with one element, namely 3. This is a well-known relationship between the diameter and the radius. The radius can be as small as half the diameter, which was the case in our first example, and it can be as large as the diameter, which is the case in our second example. Or it might be somewhere strictly in between. So in this video, we define the distance between two nodes, the eccentricity value of a node, and the diameter and the radius of a network. In the next video, we'll also assign weights to the nodes and see how this changes our definition.